There's a famous star in the Orion constellation, and it's nearing the end of its life. This news has been spreading like wildfire across the internet. A new unpublished study suggests that this star, which is one of the brightest stars we see twinkling in the night sky, could be gearing up for a massive explosion. A supernova! The cosmic event that lights up the sky unlike anything and leaves astronomers rubbing their eyes in disbelief. And this might happen within our lifetime. Welcome to Youniverse Revealed. It is believed that the red giant star Betelgeuse, also known as Alpha Orionis, located on the left shoulder of the Orion constellation, is nearing the end of its fuel supply within its core. A red giant forms when a star runs out of hydrogen fuel for nuclear fusion. This marks the beginning of the star's dying process. For Betelgeuse, once the star consumes the last of its fuel, its core will collapse. It will simultaneously eject the star's outer layers at incredible speeds of up to 25,000 miles or 40,000 kilometers per second. This explosive event is what astronomers call a supernova explosion. In the case of Betelgeuse, this event will be a remarkable spectacle visible to observers on Earth. Given that Betelgeuse is relatively close to us at only 700 light years away, the ejected layers of gas and dust will shine intensely. This supernova explosion is expected to appear as bright as a full moon in our sky for several weeks. All the sun's energy will be unleashed into the cosmos in just 1 second. But why is a supernova explosion so important? And are we connected to these cosmic explosions in any way? Well, let's understand. Only a few stars go supernova. As stars journey through their cosmic lifetimes, they follow a predictable path. Most stars, like our sun, gradually cool down as they age. They reach a stage where they become what's known as white dwarfs. Since our sun isn't massive enough to trigger a stellar explosion, it would never end up as a supernova. Supernovae occur only in stars that are larger than 8 to 10 times the mass of our sun. In a typical galaxy containing about 100 billion stars, only a tiny fraction have the potential to become supernovae. The most recent supernova witnessed within our Milky Way galaxy was Kepler's supernova in 1604. It appeared shortly after Tycho's supernova in 1572, and both were visible to the naked eye. While we haven't directly observed newer supernovae, scientists have discovered remnants of more recent ones. Observations of supernovae indicate that, on average, every century witnesses 3 supernovae within the Milky Way. A supernova emits tremendous energy. This energy is equivalent to what the sun releases over its entire lifetime. It shines brighter than the entire galaxy combined. Supernovae are crucial sources of elements that are heavier than iron in the universe. Even the iron in your blood can be traced back to supernovae or similar cosmic explosions that occurred before our sun even formed. In short, supernovae are vital for sustaining life. And the nearest star that is nearing the end of its life and is most likely to go supernova is Betelgeuse. Betelgeuse is a huge star and is called a red supergiant. It's typically the 10th brightest star in the night sky and the second brightest in its constellation, right after Rigel. This star is less than 10 million years old and has changed rapidly due to its large size. Scientists predict it will eventually explode in a supernova. However, within the astronomical community, there exists a prevailing belief that Betelgeuse isn't quite ready for an explosive demise. Yet, the researchers behind the study present a contrasting viewpoint. So what evidence has led them to diverge from the prevailing perspective, and what exactly is the truth about Betelgeuse? Well, let's find out. Betelgeuse is undoubtedly a red giant star. It's already used up its main fuel, that is hydrogen, and is now turning helium in its core into heavier elements. When a star runs out of hydrogen, it's a noticeable event. Stars without much hydrogen need to use more energy to ignite the helium they produce during fusion. This causes them to expand, sometimes dozens of times larger than they were before. As they expand, they also become cooler and appear more red in color. Betelgeuse, at approximately 10 million years old, is considerably younger than our star, which is nearly 5 billion years old. Despite being relatively young, Betelgeuse possesses significantly greater mass, leading to a faster consumption of its materials and consequently a shorter lifespan compared to stars like our sun. The lifespan of a star is closely related to its mass, and astronomers are well aware of the immense size of Betelgeuse. Its radius spans an astonishing 640 times that of our sun. If it were at the center of our solar system, its outer atmosphere would extend far enough to engulf even Jupiter. But unlike a neatly shaped sphere of plasma, Betelgeuse appears more like a jumbled mass of bubbling gas, adorned with dense clouds of dust. This irregularity in its structure makes it challenging to pin down its exact diameter. So, figuring out just how wide Betelgeuse really is indeed a challenge. This obstacle stands in the way of scientists fully grasping Betelgeuse's lifespan. That's because estimating how much longer Betelgeuse has left to shine depends largely on how huge its size is. The greater the mass of the star, the shorter its lifespan. Some calculations suggest that Betelgeuse's mass could be anywhere from just under 10 to a little over 20 times that of the Sun. But in a recent study, a group of astronomers led by Hideyuki Seo from Tohoku University in Japan proposed that Betelgeuse might be larger than what many researchers think. This idea is based on Betelgeuse's known behavior of pulsating. This means it expands and shrinks, and its brightness changes regularly. Notably, Betelgeuse brightens and dims about every 420 days. But during the fall of 2019, Betelgeuse experienced a notable decrease in brightness, diverging from its usual cycle of brightening and fading. Within a few months, the star's luminosity had diminished by approximately 60%, marking an event now recognized as the, quote, Great Dimming. The abrupt reduction in brightness prompted speculation among scientists about the possibility of Betelgeuse entering a, quote, pre-supernova phase. This phase precedes a massive star's explosive supernova event. Furthermore, Betelgeuse shows some other interesting behaviors that occur regularly in the star's internal structure. Astronomers believe these are due to additional turbulent activities happening inside the dying star and might trigger an explosion. This led to the anticipation that Betelgeuse might go supernova any time now. By April 2020, Betelgeuse had reverted to its usual brightness, yet the cause of its previous dimming remained a mystery. It wasn't until scientists analyzed data from observatories, including NASA's Hubble Space Telescope, that they uncovered the reason behind Betelgeuse's Great Dimming event in 2019. The investigation revealed that Betelgeuse had undergone a significant event called a surface mass ejection, ejecting a massive portion of its surface material into space. This material was thrown millions of miles away from the star and cooled down to form a dust cloud. It was the dust cloud that obstructed the star's light and caused the dimming. Surface mass ejections are a relatively common occurrence for stars. Even our sun routinely releases material from its outer atmosphere, known as the corona, through coronal mass ejections. The mystery of Betelgeuse dimming was thus resolved. But what about the finding of Betelgeuse's increased mass by Seo and his team? The information utilized by Seo and his team to support their theory was most probably influenced by the presence of dust and gas clouds enveloping Betelgeuse during the event of the surface mass ejection. It likely led to incorrect measurements of the star's apparent size. This might be the reason the star appeared larger. When we observe the sun, we see a clear surface with a sharp edge. Betelgeuse, being a red supergiant, is fluffy and swollen. Its visible surface, called the photosphere, is hidden beneath many layers of molecular gas and dust clouds. Red giant stars often release materials violently. Now, the publication of Seo's paper happened at the same time as an unexpected increase in the brightness of Betelgeuse. This prompted some enthusiasts to speculate that the star might be on the brink of exploding. However, other astronomers remained skeptical. They argued that Betelgeuse appears too bright to be nearing the end of its life. Older red giants usually dim gradually due to material expulsion. Betelgeuse, on the other hand, has consistently been one of the top 10 brightest stars in our sky for at least the past century, despite its regular fluctuations in brightness. Moreover, infrared observations conducted over the past 50 years have shown no notable changes in its brightness. This indicates that the dimming was likely caused by a change in the way light is blocked around the star, rather than a fundamental change in the star itself. And this is not the first time Betelgeuse has taken the limelight. Misunderstandings about Betelgeuse's outer atmosphere have often led to scare stories and rumors. Some of these stories suggest that the star will explode within a year, with exaggerated claims about what would happen if it did. These rumors tend to pop up at certain times and are often connected to wider misunderstandings about astronomy. They can also be linked to doomsday predictions tied to the Mayan calendrical apocalypse. Despite the exaggerations and hype about Betelgeuse's imminent explosion, scientific studies indicate that a supernova event isn't expected for perhaps 100,000 years. It has been clarified that though Betelgeuse is indeed due for explosive supernova, it's not happening anytime soon. And most importantly, whenever Betelgeuse goes supernova, life on Earth will remain unaffected. Betelgeuse is not positioned close enough to affect life on Earth. Gamma-ray bursts, X-rays, ultraviolet radiation, or any form of ejected material from the star are unlikely to have any impact on our planet. All you need to know is that the light emitted by Betelgeuse requires roughly 700 years to travel and reach Earth. Therefore, every time you observe Betelgeuse in the night sky, know that you are witnessing the star's appearance as it was 700 years ago.